Hey, Zach here. This is bad. Real bad. I accidentally said the word math in public, and now the entire neighborhood's dogs are after me. And what's worse, I'm stealing a joke from Scott the Wand! Ah!
Hello everyone, you know what time it is. Today we are going to do something a little different because technically this video isn't supposed to exist. Yet here we are. Today we are doing an experiment, and we are doing one with these. It all comes full circle, don't it? These go by many names, but like a normal person, we are going to call these Oreos. Good for your milk, bad for your health. Now, Oreos have had many different types of flavors over the years. The most popular ones are the regular Oreos and the double stuffed Oreos. They are the exact same price in most stores. Now, the package on these Oreos clearly labeled them as double stuffed. But is that really true? Well, you could easily look that up on Google, but for the purpose of saving my math grade, we are going to see today, do the double stuffed Oreos really have double the filling? Or can it be secret with false advertising? Objection, Your Honor. These cookies are liars. So how are we going to decide on this? Well, there's a few ways we could do this. We could look at the cookies. Not very effective. So instead we are going to measure the cookies to see if the Oreos have double the filling or not. We'll take a random sample of 6 cookies. Five cookies. And we'll use a scale that I totally didn't steal from my teacher to measure the weight of the filling. And we'll do the same for the double stuffed ones too. Boom. We could use this data alone to make a conclusion, but I value my math grade, so we're going to do more. So the first thing we have to do is check our conditions and see if we should even do this in the first place. And if the conditions aren't met, then I just wasted your time!
What am I voting for?
The first condition is if our sample is less than 10% of the entire population. Yeah, I'm pretty sure 5 Oreos is less than 10% of all the Oreos in the world. And if it's not, The second thing we have to do is check whether the sample was chosen randomly or not. So how did you choose your sample? And finally, we make sure the data isn't skewed. Almost all the numbers are the same here, so maybe? So now that all the conditions are met, we can find the p-value. But Zach, what's a p-value? If you're really interested, you can read this. All you need to know is that this will help us determine if we should reject the null. So let's calculate the p-value then. You'll know what you'll need for this. An equation? Yep. No! But lucky for us, our good friend, the calculator, can do all the work for us. Be thankful the robots haven't decided to take over yet. On your calculator, press the stat button, then in the test section, go to the to sample t-test option. Oh yeah, make sure you put all your data into the list. And also set this thingy here to the appropriate setting, calculate, and there!
Now what?
Well, the p-value is right here. Assuming our null is true, this is the probability that we get the statistics of the double stuff, and we use this to determine the significance. We most often use 5% as the threshold, and since the p-value is less than 5%, we conclude that the result would be too extreme for the null to be true, and say that double stuffed Oreos do not have double the filling. But what if that's not enough to convince you? Well, here's what we should do. First, we go through the 5 stages of grief. Right now, I'm on bargaining. And then we'll construct a confidence interval. This is the range in which the true mean lies. For this, we'll need the means of the data, standard deviation, and this. When calculating a confidence interval, we need a percent interval to go off of. 95% is the most commonly used. Why not 100%? So in this equation, we take the difference of the two means, plus or minus the critical value at 95%, times the square root of the sum of both standard deviations squared, divided by the sample numbers. Okay, after we plug in those numbers, you know what time it is. Hyper-solving time! Now that we have our range, we can say that we are 95% confident that the interval from 3.32 to 4.68 captures the difference in the true means of cream from regular Oreos and double stuffed Oreos. Since that range does not include 2, we can use that to say that double stuffed Oreos do not have double the filling. So that's it. Our research says that the double stuffed Oreos don't have double the filling, but in fact have more filling than regular Oreos. But what if? Stop saying what if! What if that's not actually true? According to Business Insider, double stuffed Oreos only have 1.86 times the filling. So that would mean that our alternative hypothesis is still true, just in the opposite way. What happened? Well, this may be the result of an error. A number of things could have happened to cause an error, such as the scale that I totally didn't steal from my teacher. Measurements might not have been accurate because maybe it was designed for larger stuff. But in many cases, there's no way to tell if you made an error, so let's just forget that I looked that up and call this investigation done. Now if you'll excuse me, I'm currently in the depression stage of grief, and this is my comfort food. I stole these from the dogs.
Meanwhile.
Where did my scale go?